In this video, we're going to be going over the derivatives of trig, and so luckily this is probably one of my more favorite topics out of all the ones that we've learned about so far, and specific to derivatives at least. Um, just because sine of x equals cosine, and then cosine of x equals negative sine, like you just gotta keep in mind that little negative, but besides that, all you really do is flip-flop between the two. Hello? Makes everything so much more easier. And then we have our derivative rules, of course. And I think it just makes everything so much more easier. We know that a derivative is a point, a specific point in time. Um, whether it relates to speed or how much money we're making or just anything really. And so here I did write two problems down just because I don't know, I think I really do enjoy derivatives. So let's see. We have 1/3 times the cosine sine of x. And so in this one we have a function inside, so we know to use u sub, or no, sorry, that's for integration. We're gonna use chain rule. Um Chain rule, so we have 6x. The derivative of that is 6. What I really like, I already know that we're going to be multiplying 6, 1/3. The derivative of cosine is negative sine of x. So we also have negative sine, and then we have f6 of x. The reason for that is because chain rule says it's f of g of x times f g prime of x. So here's the like 6 right here's the prime. We multiply that, we get 6/3 negative sine 6x, and then that turns into 2. So that turns into -2 sine of 6x. Super simple. I love. And then here we have another chain rule. We have, x equals, yeah, x equals x, or you know g equals x 9 negative 2 minus 2. G prime is 9x to the 8th. 2 goes to 0, and so the derivative of sine is cosine, so we just put cosine, plug that back in, and then we multiply it. This literally drops down at the front, and boom. It's as easy as that. Sometimes problems do get a little bit more complicated and they require probably, sometimes it could be a mix of things. I feel like like it could be a mix of power rule and product, um, or quotient and chain. And so it's just important to keep all of these rules in mind. And I'm definitely gonna have these on my reference sheet so I don't forget anything. And yeah, um, like I said earlier in the video, you just really just flip between these two, which I love. And it's the same thing when it goes to integration. You can just easily work your way backwards. And there's plenty of integration rules to keep in mind when working on the integrals of derivatives. And then it's also to keep in mind, important to keep in mind when working on more complex problems, especially in terms of integration, when you have to solve for cosine 3 pi over 2 to use a unit circle, and cosine is x while sine is y. And so just something to keep in mind when trying to solve for more complex equations. I want to say that the derivatives of trig and also the integrals are going to be one of my stronger suits on the exam, just because it goes back to the basics and we just switch to letters and words rather than numbers. And if any students are having issues or trouble with understanding on like why it works the way it does, my biggest thing is just understand that it flips
And also go back to the basics. It's just like saying this. Or when you're doing the integral, it's or what would be an integral? I'm trying to think of one. Going back to the roots and going and building from that. Also, like the rules, just continuing to work on that, and maybe a numerical setting, and then switching over to numbers, and then I can see how students can get this confused, but just remembering that anytime you see parentheses and a function inside that, chain rule. And then just taking it one step at a time, writing everything out, even if you think that you don't need to, just to make sure you don't miss anything. And yeah, this is definitely one of my stronger suits. And I do expect some similar problems. There might be something that requires quotient rule or something else on the exam, and I hope to be ready and prepared for that.